Imagine a robot moving faster, stronger, and more agile than any human, and suddenly snapping into what engineers call an attack state.
All on camera. That's exactly what Unitree's latest robot demo showed, and the footage has researchers and tech enthusiasts around the world stunned. Welcome back to NeuroWire Signal, the channel that decodes the real technology shifts before they hit your timeline. If you want insight instead of recycled headlines, hit like and subscribe. It helps more than you think. Unitree, a company known for its agile quadruped robots, just unveiled their latest model, and it's unlike anything we've seen before. On camera, the robot performed feats that seemed almost superhuman: rapid directional changes, lightning-fast jumps, and an attack mode that displayed unprecedented coordination and strength. This is more than a toy, it's a glimpse at the future of robotics, and maybe something more unsettling. Unitree's latest model in action. Unitree has been steadily improving its quadruped robots for years, but this new model represents a huge leap forward. Unlike earlier versions, which were impressive but predictable, this robot demonstrates dynamic agility and reflexes that rival trained animals or even humans in certain tasks. During the demo, the robot navigated complex obstacle courses, adjusted its gait to uneven surfaces, and responded to sudden changes in the environment almost instantaneously. Then, the moment that shocked everyone, it entered what the company calls an attack state. In this mode, the robot's movements became faster, more precise, and highly coordinated, almost predatory. Engineers noted that this state is designed for emergency scenarios, where the robot must react to immediate threats or challenging tasks. Seeing it on camera, however, was both awe-inspiring and unsettling. What makes this robot superhuman?
The term superhuman isn't exaggeration. The robot's sensors, actuators, and AI processing
Allow it to calculate dozens of movement possibilities in milliseconds. It can stabilize itself mid-jump, correct balance while running on uneven terrain, and apply calculated force to objects in its path, all in real time. Human reflexes pale in comparison. While a person might take a fraction of a second to react to a falling object, this robot predicts outcomes, adjusts posture, and executes responses almost instantaneously. The combination of AI reasoning, high-speed motors, and adaptive algorithms gives it this edge.
The attack state explained. Unitree engineers explain the attack state as a high-performance mode designed for tasks requiring extreme speed, strength, and coordination.
In this mode, the robot prioritizes efficiency, ignoring normal energy-saving behaviors to maximize performance. Every joint, sensor, and actuator is fully engaged, allowing it to perform complex maneuvers at a speed and precision level previously unseen in quadruped robots. While the name attack state might sound aggressive, the intended use is practical. Search and rescue operations, disaster response, or military exercises where rapid, precise action is required. Still, watching it execute moves that look like controlled combat on camera is undeniably striking. Why researchers are stunned. Researchers in robotics and AI are calling this a watershed moment.
Quadruped robots have long struggled with dynamic stability, meaning adjusting to unpredictable environments in real time.
Most robots can walk or run on flat terrain, but stumble on uneven surfaces or in high-speed maneuvers. Unitree's new robot, however, combines adaptive learning algorithms with high-performance actuators, allowing it to respond faster than a human could anticipate. In the demo, researchers noted that the robot could calculate and execute hundreds of possible movement trajectories in milliseconds, a level of speed and precision that redefines expectations. This is not just hardware advancement, it's AI reasoning and control at a new level. Applications beyond demonstration.
While the footage of the attack state looks cinematic, the applications are practical. Quadruped robots are being explored for search and rescue,
navigating rubble and unstable terrain where human access is impossible, military and security, rapid deployment in hazardous situations with high maneuverability, industrial logistics, carrying loads in unpredictable environments like construction sites or warehouses, scientific research, traversing remote areas like forests or glaciers to gather data without risking humans. The attack state essentially allows the robot to operate in extreme scenarios where speed, agility, and stability are critical. Why this demo feels different? Past robot demos often involved slow, controlled movements on smooth floors. This video is different. The combination of high-speed motion, adaptive AI, and an activated mode that prioritizes raw performance makes it feel almost alive. Viewers consistently report that it feels more like watching a trained animal than a machine, which is exactly the leap Unitree seems to have achieved. This is why the video is going viral. It's not just about capability, it's about presence and autonomy.
The technology behind the moves. Several key innovations make this possible. Advanced actuators, allowing precise, high-speed control of every joint.
High-frequency sensors, capturing terrain data and balance in real time. Adaptive AI algorithms, calculating multiple possible trajectories and selecting the optimal movement instantly. Energy optimization, switching to attack mode for peak performance while balancing battery consumption. Together, these elements create a robot that can react dynamically, plan ahead, and perform superhuman feats of movement. Ethical and safety considerations. Watching a robot snap into attack state raises natural concerns. If such machines are deployed widely, how do we ensure they are safe, predictable, and aligned with human intentions? Unitree emphasizes that the attack state is a controlled performance mode. However, the demo forces the industry and the public to consider, at what point does a machine become too capable? How do we regulate AI-driven physical systems that move faster and more efficiently than humans? Engineers are already discussing safety protocols, geofencing, and restricted operational modes to prevent misuse. These conversations are essential before mass deployment. The future of quadruped robotics. This demo is likely just the beginning.
Quadruped robots are evolving from simple delivery or surveillance machines into highly agile, reasoning-powered systems.
In the next 5 years, we could see robots that navigate disaster zones autonomously, assist humans in hazardous industrial environments, act as intelligent companions in large-scale logistics operations, support emergency medical response teams by delivering supplies quickly. The line between robot and superhuman agility is blurring, and Unitree's latest model offers a clear glimpse into that future. Why this moment is significant. Unitree's attack state demo isn't just a viral video. It represents a paradigm shift in robotics. We're no longer talking about robots that need constant human oversight for movement. We're talking about machines that can understand context, react dynamically, and operate at peak human-plus levels of performance. This has implications not just for robotics, but for AI research, ethics, and society at large. How do we coexist with machines capable of superhuman speed, strength, and precision? If you want to stay ahead of the biggest tech breakthroughs before they hit mainstream headlines, subscribe to NeuroWire Signal.